Hello, class. So this is the last day before our STAAR test tomorrow. So I need you to do your best. So in this video, we're just going to kind of go over a few last-minute little things. So always remember this. If I do this test with one eye closed, one hand tied behind my back, and hopping on one foot, do I get an A for effort? Remember, the only way you can get an A is if you answer all the questions correct. This is not like the YMCA. You've got to actually perform. So here are a couple things I need you to perform on. First thing, let's talk about the Pythagorean Theorem. Okay, remember the Pythagorean Theorem is only used on right triangles, and it's only used if we know two of the side lengths of the triangle and not the third side. Okay, so we know that this rectangle right here plus this rectangle right here, that if I were to add their areas together, a squared, that's going to be this piece times this piece, gives you the a squared, and the area over here, which is b squared, if I add these two together, it's going to give me c squared. Sometimes the STAAR test does ask you about the definition of the Pythagorean theorem, and we have to remember that the area of this one plus the area of this one is equal to the area of this square, and they are all squares. Okay, so keep that in mind. Now, to use the Pythagorean theorem, we use it for a couple things. Okay, one, we use it if I know this side and I know this side. This is how we find c squared. So we would do a squared plus b squared, add those two squares together, and then remember to take the square root of that answer. Okay, now if you have one like this where we're given one leg and we're given the hypotenuse, we need to remember that this is our A, so we'd square it. The missing one is our B, and the 10 is our C. I've had several of you trying to do this one incorrectly, so we got to remember that it's going to be 6 squared plus B squared is equal to, and in this case, 10 squared. So we would do 36 plus b squared is equal to 100. And you've got to subtract the 36 from both sides to get b squared is equal to 64. Then you take the square root of each. So you'd end up with b is equal to 8. So this measurement right here would be 8. We've got to remember that. Okay, you've got to remember that you've got to subtract if we only know one leg and the hypotenuse. Okay. Scatter plots. You need to remember scatter plots are used to show a possible relationship between two sets of data. Okay, so here are some example scatter plots. So if you'll notice in this first one, there is a general downward trend. So we would say that it's a negative slope or a negative correlation. This one is a strong negative correlation. This one has a positive correlation. Okay, and this one has no correlation. It's all over the place. And what we got to do is we got to remember that when we're dealing with a scatter plot, we make predictions. So you draw a line through the middle of it so that you can make predictions. So if I wanted to look at like 12 or 13, we then could just draw a line up and be able to see. And wherever it hits over here, that would be the value that we're looking for. Okay, so scatter plots show just trend data, but sometimes you do have to make predictions. So we use that line going through that. That's called a trend line to make our predictions. Slope and y-intercept. We need to remember that there are several ways to find slope. Okay, one, from a graph, okay, we know that we're going to use delta y divided by delta x. That would mean that we would, well, delta y, delta x is really from a t-chart, and we'll look at that one in just a second. Okay, but if you're given a graph, we know that you pick two good points, and we do rise over run, okay, or fall over run, whichever the case may be. So we got to remember that. Sometimes they're going to give you just points and ask you what the slope is. That's where we use our slope formula. And remember that slope formula will be on the formula chart. So if we were given a graph like this and we're looking for that slope, remember, choose a good point, and then we do, in this particular case, fall. So this one is a fall over a run. So what did it fall? It fell 3 and it ran 6. So that means it has a slope of 1/2. Okay, you could also use this point and use our formula to figure that out. Okay, now the one thing I've noticed that several of you are doing, which is not a good thing, is we're not paying any attention to the scale of our graph. Please make sure that you pay attention to the numbers on the x and the y axis to determine what numbers to count by when you're doing rise over run or fall over run. Well, what if you're given a t-chart? This is where we do our delta y and delta x, where you pay attention to what's happening here, what's happening here. Okay? So in this one right here, we're increasing by 3. We're increasing by 1. So we have a slope of, and this is y divided by x, 3 over 1, which is just 3. Okay, now if you're given a horizontal t-chart, we're doing the same thing, but we've got to remember we do y first. So here's our y, and this, what are we doing as we go from left to right there? We are decreasing by 4. And as we go on the top, we are increasing by 1. So this one has a slope of -4. So we have to remember those kinds of things about slope. Now what about from an equation? Okay, we got to remember that this number right here, this is our slope. Okay, or our m value. Okay, or sometimes we'd call it a k value if it is a proportional relationship. Okay, we know the 5 is our b value or our y-intercept. Okay, and this is the point in which the graph is going to cross the y-axis. Okay, now this one, because it's a +5, we know that this will not be a proportional relationship because it does not contain 0, 0, or the origin. Okay, so just kind of remember those kinds of things. Okay. Geometry. We know volume and surface area are really big. Okay, so for volume, we know that we're going to do capital BH, and we know the capital B stands for area of the base. Area of the base. And we know that in a cylinder, we've got pi r squared times h. We know for pyramids and cones, 1/3 area of the base times the height. And for spheres, 4/3 pi r cubed. We need to remember that capital B means area of the base. Okay, now we also have surface area, and I'll come back and talk about that in just a few minutes, hopefully. Functions. Okay, we know with functions, okay, we've got several things that we're dealing with. Remember, this is just an input-output table. Okay, and we've got, for functions, we've got mappings, and a mapping looks something like this. We need to remember that we can only have x's go into y's. We can only have one line coming from an x. So this one's good, but this 5 is bad. Okay, because that's telling me the points of 1, 2, 2, 3, and then it's got 5, 4, 5, 5, and 5, 7. And remember, in a function, x is what's king. If you have any x's that repeat, it's automatically not a function. We also have to remember that from a graph, how do we determine a function? With the vertical line test. Anywhere along the graph, if I drop a vertical line, if it hits the graph in more than one place, it's automatically not a function. If I give you ordered pairs, we're looking for the x's. If all the x's are unique and different, then we know it's a function. If any of the x's repeat, we know that it's not a function. Okay, so functions are important to understand. Similarity and scale factor. Okay, remember, similar figures are just two shapes that are similar, and they're similar when they're the same shape, different size, corresponding angles are congruent, but this one's the most important. Corresponding sides are proportional. Okay, so that means that you can set up a proportion to solve for the missing value. But what we have to remember is that in 8th grade, what they're really looking for is, do you understand how to set up the proportion? That's what we're looking for. So you can do that from the name by looking at, AB goes with EF, BC goes with FG, AC goes with EG. So if they give you a name, then we can easily figure out similar figures. Okay, scale factor. Okay, if they talk about scale factor, what is the scale factor going from one to another? If I'm looking for the scale factor from ABC to EFG, then we would actually do it backwards. Okay, so if I'm going from big to little, then we know that we've got to have a fraction that's going to be less than 1. Okay, if we go from little to big, we got to have a scale factor greater than 1. Okay, so if the example that I'm using says the scale factor is going from, what's the scale factor between the two in this one? Because this is greater than 1, I'm going from this one to this one. But what if I was going the other direction? The other direction then would have a scale factor of 2 to 5, okay? Because I'm going from big to little, okay? So if we were in this one right here, it says, given the vertices of the triangle, find a dilation by a scale factor of 3. Okay, so in other words, figure out, okay, what happened. We're going from this original triangle here to this new triangle. So how would you figure out the scale factor of that? Okay, well, it's telling us that it's 3, but there's a couple ways that you can tell. Okay, one, just look at your side lengths. I know this side length is 2. This one is 1, 2, 3, 4, 5, 6. Okay, so what did I do to go from the small triangle to the big triangle? I multiplied by 3. You can also look at that in terms of the coordinates. What did I do to each of those coordinates to get the new ones? 1 and 2 to get 3 and 6, I multiplied by 3. Okay, 3 and 3, 9 and 9, multiplied each of those numbers by 3. So that's how we're talking about a dilation. Okay, remember, dilation is the only transformation that affects congruency. The only one. All the others, this figure will be congruent, but in a dilation it won't be. Scientific notation. You got to remember that the number here in the front has to be a number that is between 1 and 10. Okay, it's going to be greater than 1 or greater than or equal to 1, but it must be less than 10. Okay, and the most important thing to remember, the exponent does not tell us how many zeros to add. It tells us how many places to move the decimal. If it's a positive exponent, it's a big number. If it's a negative exponent, it's a small number. Okay? So here are some examples. So this 4,900,000,000, okay, we would write that as, first off, we would take our significant digits, write it as 4.9, okay, and then times 10 to the, and how many places did we move the decimal? We ask ourselves 3 questions. Where was the decimal? Where did I move it to? How many places in between? 9. Okay. Now, we also need to remember that I've shown you how to do some of this stuff on the calculator, where you could put your calculator in scientific notation mode, and that's another way of working these. Okay, now if you have a small number, a number less than 1, we look at the same thing. We look for significant digits. So the 55, we put a decimal in it so that its value is between 1 and 10, so it's 5.5. Then times 10 to the, and we ask ourselves the same 3 questions. Where was the decimal? Where did I move it to? How many places in between? But because it's a small number, it's going to be a -3. And that's all we're doing. That's how we work that. Okay. Interest. You need to remember that there's 2 types of interest, simple and compound. The most important thing to remember is that when we're dealing with this first interest formula, what I get as an answer is interest. If the question asks, how much money is in the account? What's the balance? What's the total amount? However it's written, okay, I'm only given interest in this one, so we have to add the principal back to the interest to find the total amount in the account. So you've got to pay attention to how the question is written. For compound interest, the type of answer we get is a total amount. It's the amount in the account. So I've told you that the A stands for all of it. Okay, all of it means principal plus interest. So if I wanted to know just what the interest is, I have to subtract the principal back out. Okay, so just some little things to help you kind of remember. Okay? For equations and inequalities, remember there's 3 basic steps. Okay, 1, get your letters on one side of the equal sign. Number 2, get your numbers on the other side of the equal sign. How do we do each of those? Add the opposites. You know, here lately we've been doing all the tricks, okay? So you don't have to write everything out, but you do have to remember, add the opposite to move things from one side to the other. And then last but not least, solve. If you have a multiply, then you do a divide to get rid of it. If you have a divide, you do a multiply to get rid of it. Here's an example. Okay, so you got 4a plus 2 minus a equals 3 minus 2. Well, the first thing we do is we add like things together. Okay, so this negative 4a and this a right here, you could put that together to make the 5a. Okay, and then we Add the opposite to move the 2 to the other side. Okay, and then we end up with negative 5a is equal to negative 1. Divide both sides by 5, and you end up with a is equal to 1/5. Okay, here's an inequality using the distributive property. Okay, so you'll notice we distributed the 2 out to the 3t and the 4. Okay, and then we could take this 9 and this 8. We could put those together. Okay, and then we begin our process. Okay, move this 6t over to be with the 2t. So we end up with 2t minus 6t gives you the negative 4t. And then you got the minus 3, so we do a plus 3 to move it over. And then you divide both sides by negative 4. Now, what do you have to remember when you divide by that negative 4? That inequality is going to flip. Okay, you've got to remember that. Okay, so last thing I need you to kind of remember, okay, and then maybe I'll go back and talk about surface area because I forgot to put that in this flip chart. It says read each of the questions 3 times. Okay, that's really kind of important. These are just some kind of tax strategy or STAAR strategies that we use. Okay, so the first time you read it, you just read it for information. The second time you read it, you pull out the information to actually work the problem and work the problem. But then the third time, I want you to go back and look at the question and ask yourself, did I answer the question? Okay, another thing, take your time. Use your formula chart on the gridables. Now, in this particular case, you're not going to have gridables to bubble because it's on the computer, but make sure that the answer that you put in to the blanks actually represent the decimal point that's there. Okay, make sure it has the value that you want, and if it's supposed to be negative, you better put a negative sign on it. And then last but not least, check over your test when you're finished. Okay, intelligent people check over their work. Please make sure you check over your work. Okay, make sure that you do it. Okay, so I wish you the best of luck tomorrow, okay, on this math test. So do your best, make us proud, show us what you know. Until next time, I'll see you later.